All right, hello. My name is Grant. I'm a developer with Bitbucket Cloud, and today I want to talk about annotating diffs. So I spend a lot of my time reviewing code, and that typically means looking at changes in the form of diffs. So here's a diff. This is a minor variant on a unified diff format. So it has a diff header, which has some header lines that we don't really care about, and it has header lines that tell you which file is changing. Those we do care about. Diffs normally have one or more diff hunks, and a diff hunk has all the changes that you would expect to see in a diff, like the important part. And a diff hunk has a hunk header, which tells you where those changes are occurring, and it of course has all the added lines and removed lines that you would expect to see. And it often has context lines, which are just unchanged lines. So hopefully none of that is too new for anybody, but that's unified diff. The changes that I look at rarely are this simple, though. They tend to look something more like this, where this is just a small patch series that I pulled out of the Linux kernel for example purposes. There's only 7 commits there. There's about 80 lines changing. And this is relatively clear, clean code, if you can see it. But when I'm looking at this amount of changes, I often want more context for a particular subset. For example, I might want to know what the commit message is for a particular set of changes. And I don't have to go through every commit to find that. Oftentimes it's important to see if changes happened simultaneously, all in the same commit. That can be very important sometimes. And oftentimes there's just a lot of detail, a lot of information associated with a particular line. So this one line change has 137 lines in the commit message. Most projects aren't like the Linux kernel, though. They'll put that level of detail typically in a pull request on a website somewhere. So when I review code, it looks more like this, or this is just part of a diff in a PR on Bitbucket. And even in this view, I often want more context. So there's a drop-down menu that has extra stuff. And I think it would be cool if we could add a show commits item to the drop-down menu, like that. And this isn't like a product announcement or anything. I'm not promising anything. Just I think it'd be cool to have the ability to show the commits that are associated with the changes that I'm looking at. And if we're being really ambitious, we could put those commits right in line with those changes, like that. Just have a link straight from, oh, this change is in this commit. And that link would, of course, just take you to the commit page, where you may or may not have a useful commit message. But what the Bitbucket team tends to have installed on their repositories is very useful integration called pull request commit links. And that will go through, and for every commit in the repository, it will try to find all the pull requests that commit showed up in. So that's really useful, for example, if you have a release pull request, which is essentially one pull request that is 10 or 20 other pull requests all together. And it's very convenient to be able to go and say, oh, where were these changes reviewed? So I use that a lot. And so back to the diff view, I think it'd be cool if that integration could have its own item in the menu, like that might be useful. And if we're, again, being really ambitious, we could put the link to the PRs right next to those lines changed. I think that would be very useful functionality. So the question is, how do we tie the commits to the changes that we're looking at? Like what would we do to do, how would we represent that? So I want to suggest an annotated diff format. So this is what I think an annotated diff should look like. It kind of looks like a unified diff. It has a header that kind of looks like a unified diff header. It has one or more hunks that kind of look like unified diff hunks. You may have already noticed the primary difference. Each line gets prefixed with a commit. And so that's the annotation, of course. Also useful, I think it would be nice to have the original line number from when that change was introduced. And that would be very useful if you're in a PR on a website and you want to attach a comment to a particular line and a change, and maybe have that comment show up in different contexts, maybe in subsequent PRs or if somebody's just browsing commits. So I think that'd be cool. There's one other piece of information we need to really make that work, though, and that's the file name, which can change during a diff. So we need to track the renames. So we just throw that in the header that already has that name information. And a detail that would become important later is I feel that removed lines should show the commit that removed them. That just seems like the most logical thing to do, for that annotation. Less important is how context lines get annotated. For my use cases, I don't particularly care about context. This could be all zeros, spaces, not important. Here, I just gave it the same hash as everything else because that was literally the easiest thing to do. Not critical. But I think that would be a useful way to represent this information. Let's look at a slightly bigger example. The previous annotated diff only had one commit. This one has 4. And you can see that all 4 show up in the rename list. Just, again, feels useful. And then you can look at the line numbers, and they do jump around. We are tracking the original line numbers. Small detail. But again, I think that would be really cool to be able to generate and use in displaying diffs for PRs in particular. So then the question is, how do we generate these annotations? What tools can we use? And Git helpfully provides an annotate command already. So let's explore that and see if we can use it for generating annotated diffs. And what GetAnnotate does is it will look at a file, and it will go through history, where in Git, history is represented, of course, as a directed acyclic graph, where each commit is a node in that graph. You don't really need to know too many details about that, except that it's often called the DAG. And going through history is often called walking the DAG. So I'll probably say that a lot. So GetAnnotate starts with a file, walks the DAG, looks at lines that are introduced, and tries to match those lines to the lines that it has in the file. And eventually, it will spit out an annotated version of that file. And here we see that there's hashes, there's line numbers. This is literally half of what we need. This is great. This is every added line and even every context line, which we don't really care about, but still cool for a diff. So let's see if we can really squeeze diff annotation in, given what Git already gives us. So if we generate a diff, start with that. Seems like a good place to start. And then we call GetAnnotate once for each file that shows up in the diff, so maybe a little slow. But that will give us half of what we need. Great. The only thing left to do is get the removed lines. And GetAnnotate has a reverse option, which will walk the DAG backwards, which is forwards through history. If you give it a file and a place to start, it will start at that place, look at the lines in that file, and then track the last time that it saw each line as it goes forwards through history. So it's not quite what we want. It doesn't annotate when the line was removed. It annotates when it was last seen. So it's off by 1 in terms of what we want, but it's close. So we can't quite get what I really want out of the built-in Git commands and maybe a Perl script wrapped around those. And there's 2 problems. One, we would have to call GetAnnotate twice for each file that shows up in the diff. So it'd be slow, not too bad, but it's also not the annotations that we want. So, all right. In theory, I think we can get what we want and be slightly more efficient about it, though. So, in theory, we'll try to replicate most of what GetAnnotate does, but do it, so that it generates the thing that we want. So we start with the diff, reasonable. We walk the DAG just like GetAnnotate does, and we know that GetAnnotate does exactly what we want for added lines, so that shouldn't be contentious. And when we implement this ourselves, at each step in the walk, we can look at every file that we care about instead of having to do multiple walks per file. So slightly more efficient. And we can walk backwards through the DAG, just like GetAnnotate reverse does. But instead of comparing it to a file, we can compare it to the diff and take the diff at each point and see, oh, this removed line matches up with that removed line. And in theory, we can annotate a diff. So that seems like a reasonably obvious approach to take. And when I was looking at doing this, I thought, OK, I can probably be clever and be faster about it. So I worked on an optimized approach. And one of the requirements to be faster is to walk the DAG once. DAG walks can be slow. So I wanted to minimize the number of DAG walks. And of course, any real implementation wouldn't actually walk the DAG twice. It would generate a cache of things that it's seen on the first walk. And I didn't want to use a cache, because that is differently expensive. For example, I think 2 weeks ago, there was a Bitbucket cloud support ticket about somebody who had an 11 million line diff that wasn't rendering properly for some reason. And I don't want to store 11 million lines, especially multiple times, in a cache somewhere where I'm walking other things. So one walk, no cache trickery. That was my goal. And I was thinking about it, and I thought, OK, we can do this if we just build up the annotated diff incrementally as we go. And I'm not sure if I implied it, but annotating a single commit is kind of trivial. Everything gets the same annotation. And so you can do that for every commit that you see. And then all we have to do is figure out a way to combine those as we walk through to build up a diff. And that should, without using a cache, allow us to get away with one walk. And if we're building up an annotated diff as we go, and we have a diff at each step, we don't even need that initial diff. That becomes extraneous. And getting rid of that is kind of in line with another performance constraint, never keeping more data than we need. And so that's no cache, no extra diff, one DAG walk, the super clever optimized approach. And I came up with that approach without really digging into the problem. And Donald Knuth has a quote that comes around from time to time. He says, "Premature optimization is the root of all evil." So when I talk about my optimized approach for the rest of the talk, you should keep that quote in mind. That is important. But moving on, let's look at a simplified single file case, see if we can actually make this work. Is it going to actually do what I want it to do? So here we have 3 commits, C on top of B on top of A, and then the state of a file at each commit. And so we want the diff from A to C, just dropping foo, adding baz, and we want to know, can we annotate that incrementally, step by step? So let's try it. Let's step to C, generate the diff from C to B, and we know that those changes were all introduced only by commit C. So the annotation is kind of trivial. Boom, there it is. And it's worth noting, if we were just annotating from B to C, just that, we would spit that out. We're done. That would be a completely valid annotated diff. But we're going all the way to A, so we have to step to B, generate the diff from B to A, and we know that those changes were only introduced by commit B. So trivial to annotate. Cool. Now all we have to do is figure out how to combine these 2 annotated diffs. All right, you can kind of look at it and stare and say, all right, foo with foo, baz with baz, should look something like that. That seems doable, like that's a reasonable sequence of steps to take. So this looks promising. This looks like, oh, I can actually maybe code this up. But before I do that, let's see if I can ignore anything to make it easier. So list of things to not worry about. First off, multiple files. Am I going to have a weird situation where I have a ton of files to track and they overlap and weird stuff happens? And it turns out no. Of course, each file is entirely independent in the diff. So just in generating a diff, you have independent files and it tells you, hey, there's your file. All you have to do is track it. Computers are good at that. So that turns out to be easy. What about renames, though? Renames get weird. All sorts of things happen. It's kind of difficult to detect renames. And again, it's the same case. Just generating the diff, yeah, it's hard for that code, but it spits out the rename. I never have to worry about that. And since each file is entirely independent, it turns out all of the interesting cases happen just in one file. So I don't have to worry about that case at all. Easy. What about merges? Now, merges are very important. That was my release pull request case, where that's basically just a series of merges, and I really want that to be annotated and annotated correctly. So let's quickly look at that, where if you have a merge and there's your DAG, it's not clear that that can work just by going incrementally, one by step by step. You kind of have that left part that looks like, okay, yeah, I know how to annotate that part, and maybe that right part I could also annotate. And they start and end at the same place, so I'll assume that I can handle that later. Just to get started, I will ignore it. Hopefully, I'll come back to it and get that working. Branches, on the other hand, where if you have the heads of 2 branches of development, and you want to compare those, and you want to annotate the diff, it's very easy to generate a diff between 2 heads. Do it all the time. But what would an annotation for that look like? At first, it kind of seems like the merge case. You have that left side where, oh, yeah, I can generate an annotation for that. And then you have the right side where, oh yeah, I could build up something there. But they don't share, the same starting point. So it's not clear that they could be easily combined. And you might be able to get around that, say, by flipping the direction of one of the walks. And it's like, oh, you go down, then up. But that gets weird where you're going backwards. So are you changing like your added and removed lines as you go along? If you annotate a diff and you get a removed line with a commit, if you go to the commit, will it be an added line? Thinking about this one hurt my head, so I just said, nope, forbidden. My code will just crash. Well, it will crash with a nice message. Don't do that. But that really simplifies the problem. That means, OK, we only care, for now, about the linear single file case. Great. All that's left to do is line up the lines. And what that means is that we have to track changes to line numbers through history. We'll be adding and removing lines. Well, we'll be coming across added and removing lines as we walk the DAG. We just need to know, how things shift. And we need to keep track of how things shift so that we can match up lines. Just, oh, these lines collide. And when that happens, we have to decide what to do with lines. That's a little hand-wavy, so let's look at a more concrete example. So in theory, if you're walking through the DAG and you have an annotated diff here, and later in that same file you run into these changes, can we line those lines up and decide what to do with them? And you might look at that, and looking at the top annotated diff, you might say, oh, B1 bar, that doesn't seem to match any line in the other diff. And it's annotated as B1 bar, meaning it goes to line 1 in commit B. But just by parsing that hunk, we know that it's actually from line 2 as well. And so we track all the line numbers we possibly can for this. And from line 2 matches up directly with to line 2 in that next change. So we're like, oh, that actually matches up nicely, and we know how to combine those. Great. Let's look at a slightly different case. So what if there's a bunch of lines coming and shifting things down? What happens? If we have this annotated diff, and then we run across these changes later, you might say, oh, D3 Baz, there is no line 3 in that other diff. But it turns out this is actually the same case. D3 is to line 3 in commit D, but it's actually from line 1. And we know that with no magic just by reading the hunk header. And so we know that, oh, D3 matches, or D1 from D1 matches directly with the to C1 changes in that next diff. Great. So there's two things to note here. First off, we only have to track line numbers. Well, I mean, I have to look at line contents to verify things, but the computer can only get away with tracking line numbers. Nice, efficient. And second off, you can't just ram these two together. You'll end up with a removed line in the middle of a bunch of added lines. That's bad diff etiquette. You need to sort lines or track contiguous hunks of changes, details. But once you handle those, you can get a nice annotated diff out of that. Cool. So this seems like something that it's easy to come up with a finite number of cases, figure it out, maybe write it on the back of a napkin type scenario. And so I did that, went through every case, plus meets plus, minus meets context, that sort of thing. Came up with these cases are obvious, these cases are forbidden, code it up, run it through some tests, find out that, of course, the forbidden cases aren't so forbidden. That's fine. You just go back, re-examine your model. It's still relatively simple. Change all the code, run it through some more tests, find out, oh, no, this isn't quite tracking line numbers correctly. So that's fine. You figure out those details. And I only rewrote this code about 3 or 4 times. Kind of felt like 30 or 40. But at the end of this, I got a good, set of code that, hey, this will annotate diffs. And it works almost every time. I say almost because there was a problem. And that problem would show up if you're going through the DAG, you run across a change. And then later in that same file, you run into the opposite change. So if somebody makes a change, then undoes that change, then you would expect that to show up in a diff as either context or to just not show up at all, because nothing changed. Of course, what my code was doing was ramming all the lines together, which is technically what happened. I mean, that's technically accurate. But nobody cares that it's technically correct. They just want it to look like they expect it to. So I needed a way to fix this problem, to make it go away. So fixing the problem, nobody cares that it's not technically broken. But I just needed to figure out which lines were duplicates. Really simple. and computers have a great way of doing that. It's diff algorithm. So in generating this diff, after running and calling diff all these times, I then had to rediff the results, and I had to do that after each step in the walk to avoid these sorts of things snowballing out, because if you have an error and you keep doing stuff, it will build. So what that looks like is if I have a suspicious set of changes, I look at that and I'm like, okay, there might be some repeated lines. Pow, run it through diff, and okay, there we are. Out pops a better diff. And the important thing here is, besides calling diff, not the command, but still the algorithm, multiple times, it slows things down. And we're now looking at the contents of the line. We can no longer get away with just tracking line numbers. So for an approach that was supposed to be optimal, or at least optimized, fast, this is very bad. It slows things down quite a bit. So that was a depressing discovery. But at this point, the code was almost feature complete. It handles linear merges or linear paths just fine. What about merges? So briefly, if you're walking through the DAG, you've got some changes that you're tracking, going through, and you run across a merge. What do you do? So a merge, when you're going backwards through history, kind of looks like a branch. You get two separate paths that pop up. All right. At this point, I had given up on being clever, and I had given up on being efficient. I just did the easiest possible thing, copy the entire annotated diff, once for each parent. And great, now I have multiple annotated diffs. For each one, you just track the parent that it expects to see next, so that when you walk the DAG, run into a commit, you feed it to the correct annotated diff, annotate, combine as usual. Great, keep walking. Get another commit, feed it to the correct annotated diff, annotate, combine, cool, keep walking. So the interesting part here comes when you run across that common ancestor, the original branch point, and you have to recombine the annotated diffs that you've been building up so carefully. But it turns out that's just line matching and decision logic. I've already done a lot of that already. This is slightly different, but not terribly different. You need to keep track of things like which commits you've run across that were merge commits, so that you can decide the proper annotation for every case. But it ends up being relatively straightforward. You can combine those diffs, no problem. So cool, I ended up with a usable, an okay implementation of annotated diffs. Let's see how like a scorecard here, how did I do? So first off, I got away with one DAG walk. Cool. I got away without even using a cache. Nice. One issue, though, is that it generates an unexpected diff. So there's no uniqueness guarantee in diffs. You can represent the same changes many different ways. And since I was generating diffs in an entirely different way than Git generates diffs, I was probably going to end up generating slightly different, which line is removed versus context. So that's not great. That's not what users expect. That's, bad. And then there's the extra diff steps where I had to rediff all the lines. And again, for an optimized approach, that is very, very bad. So overall, this is clearly not optimal. But, it was functional. And at some point after writing this code and, coming to this conclusion, I got roped into going to a mercurial sprint. And at some point during the mercurial sprint, I got roped into talking about annotated diffs. And so I presented my, oh, hey, cool, there's this incremental thing that I'm doing. And I got some feedback on my approach. And I said, yeah, no, you're right, this is pretty bad, but you guys are DAG experts. You live and breathe DAGs. Tell me the correct way to do this. And they said, okay, so you start with a diff. And I'm like, okay, yeah, sure, sounds reasonable. And they said, you walk the DAG forwards. I'm like, okay, I'm with you, sure. And they said, you walk the DAG backwards. I'm like, whoa, backwards DAG walk, too slow, can't do that. And they said, of course you wouldn't walk the DAG backwards, you would build a cache on the first walk. I'm like, whoa, cache, no. And I was really digging in my heels about this being like the slow way, what they were recommending. But I realized afterwards that I hadn't actually gone back and asked myself, wait, why is it so slow? Like, re-examined it in depth. So let's do that now. So this is the slow way, the obvious way, like the initial theoretical, straightforward approach to annotating diffs. So starting with the diff, what's that cost us? Turns out it limits the number of lines you examine. So if you have the diff, all the changes that you care about, and you step through walking the DAG, and you find a set of changes that aren't in that diff, you know you don't care about them. You have to track line numbers, but you can throw everything else out. It's like, OK, cool, skip it. And that works at the file level, too. If you have a file that you run across and that file is not in the diff, throw the whole thing out. So that's occasionally a nice optimization that you can do. You can also skip context during the walk. And the only reason that we tracked context in the incremental approach is that we needed to spit context out at the end. We have to keep that and move it along with everything else so that we generate a reasonable diff for the user. But generating that initial diff gives us all the context we'll ever need. And since we don't really care about annotating context, or at least I didn't, you can just skip it when you're looking at everything else. And since some diffs are like 80, 85% context lines, if you have a ton of single line changes, that's not a bad optimization. But most importantly, it's consistent with user expectations. It generates the diff that the user expects to see. So you can do things like generate a diff and then say, oh, I want to annotate that, and then get the same diff annotated. Way more useful than what I was doing. So that turns out to be a very important step not to skip. And then let's look at the real performance killer, the double DAG walk. So of course, any real implementation would not double DAG walk. It would use a cache generated on the first walk. But it turns out that cache is actually really efficient. It only needs to store line numbers. And since we're only looking at removed lines at that point, we only need removed line numbers. And we don't need it like per line. We can just store ranges of lines. So that's a really efficient cache. And we know that we'll never need line contents because we already have all the line contents we would ever care about in that initial diff that we generated. So this turns out to be kind of a stupid thing to skip. It's a very important step. And this isn't so much the slow way. It's probably the fast way. And I say probably because I haven't gotten around to implementing it yet. Don't know how I can screw this one up yet. But it seems like the correct thing to do. And so hopefully I've convinced you that annotated diffs are interesting and useful and can be generated efficiently, even if I have yet to do so myself. So thank you.